Okay, welcome to chapter 4. Today I'm going to do 4.1 and I'll probably do it in 2 videos, so watch both of them. Okay, so we now have calculators, right? And hopefully our knowledge from chapter 3, you maintained it because you'll need it here in chapter 4. So chapter 4 is ratio and rates. Here's a typical ratio. Back to our alpacas. I have 3 alpacas in my herd for every 4 that you have in your herd. So that's a ratio. That doesn't mean that I have 3 alpacas and you have 4. What it means, that's the ratio. I might have 6, in which case you would have 8, which is the same ratio. And you might want to think about equivalent fractions here because that's what it is. That's the foundation of ratios and rates, is an understanding of equivalent fractions, like 1/2 equals 4/8. Now you can pause this video at any time you want. 4.1 has the introduction to the whole chapter, so we got a little bit more words to deal with. Hopefully you'll read this ahead of time to get a little bit of understanding. But of course you can pause this video at any time you want. So here we are, 4.1, ratios, making comparisons. So in the real world, we have all these numbers, right? The number of births in 2014 is right there. Number of deaths, number of violent crimes, the federal budget, 3.9 trillion, that would mean 12 zeros, move the decimal 12 places. Median income in 2005, and the list goes on and on. All these statistics above here are absolute numbers, meaning they're not relative or being compared to anything else. They're simply the raw count of something. If you wanted to know whether household income has gone up or down, this isn't going to tell you. This number, 55,755, is not going to tell you that. You need to compare, right? Ratios is about putting numbers in context and making comparisons. For example, we could compare them to the U.S. population. Like, for instance, here's one. There's 62.9 births per 1,000 women aged 15 to 44 in 2014. That's an important statistic. That's a ratio. Per means 2. So that clearly is a ratio. And you can use that ratio to compare over years or against other countries. For example, this is a good graph to explain how you use ratios and how they make sense. The bottom line is green, where the top line is blue. The top line is the number of births in the United States total, which is over here in the millions. So there was 3 million births in 1920. There was 4.5 million births in 1960. Down here, there was about 4 million births in 2015. That's the number. Notice the number was going up and has been going up since about 1975, the number of births, but yet the rate is going down. It's been going down since the 1960s. Why is that? Well, it's because less women, go back to here, there are less women aged 15 to 44 having births per 1,000. For every 1,000 women, there's less births in 2015 than there were in 1960. However, the number is going up because the population is going up. So that's how you compare it across time. Bottom number is a ratio or a rate. Top number is just a number. So just to clarify this one more time, notice that in the figure above, the absolute number of births started rising in the 70s. here. The absolute number of births started rising in the 70s, while the rate per 1,000 women aged 15 to 44 was relatively steady and even declining slightly. This illustrates the need for context. Births rose along with the population. Only looking at the rate do we get an accurate read on the question, are women having more babies? So it's the rate that we use to compare when we ask questions like that. Here we're looking at median household incomes. That's the median household income. Recall what that means. The median income of $55,775 means that it's right in the middle. 50% of all households make less than that, and 50% make more than that. So this is for 2015. You're comparing median incomes across different states. See, Michigan's in the blue, it's about in the average. New York's a little higher than average, but then they have higher taxes. So North Dakota's probably high because the gas and oil fields up there, they pay really well. Same thing in Wyoming. California's high, but they have high taxes. So you're just comparing. Low states would be Alabama, Mississippi, Arkansas. They're down here. So this map allows us to compare different states against the median income. Here's another way we compare parts of the whole. This is the United States budget in 2016. Revenues are the money that the government took in with taxes, things like that, mostly taxes, income taxes, business taxes. Spending is what is spent, what the government spent. You can notice that when you compare the amount of money that it took in revenues to the amount of money we spent, there's a gap. We spent more than we took in, and that's called a deficit. You can also look at what was mandatory, part of the whole, part of all the spending. This greenest part, or teal part, was mandatory spending. Those are things like Social Security or Medicare. They're mandated by law. That's why they call them mandatory. Every year the government then must make discretionary spending. And discretionary spending is thousands of different things that they vote on and allocate money to. This here, this 0.2 trillion, is the interest on the debt. Not just this debt, but all the debt that the United States has accumulated, which was about $19.5 trillion in the end of 2016. So there's more comparisons. This is what we're talking about here, is just comparisons. Here's a pie chart giving a breakdown of all the parts, right? So this is federal spending, and this is discretionary spending, which is up here. This discretionary spending is broken down further here into the different categories where the money was spent. So in this case, it's saying things like military spending made up 18% of the deficit, right? I'm sorry, of the budget. Social Security made up 23%. So we're looking for comparisons. And what does that 23% mean? It means that of all the money that was mandatory, 23% of it went to Social Security. There's the interest on the debt. So again, these are just comparisons, and for comparisons you can use percentage for comparisons too. Percentage is nothing more than just a ratio. 6% means 6 over 100. 23% means 23 over 100, etc. So in this chapter, we're going to cover comparisons like these and go over all the associated vocabulary. All these comparisons are a form of a ratio. So we're going to start with ratios. This is the foundation. This is 4.1, ratios is the key here. If I have 30 alpacas in my herd and you have 50, we can compare the size of our herd by forming a ratio of 30 to 50. Make sense? Sure. And you can also write it like this, 30 to 50. That's pretty easy. Now the ratio gets tricky because we typically simplify this ratio and we don't use the absolute number. In other words, you'll see here, instead we would say that the ratio of alpacas in my herd to your herd is 3 to 5 or 3 to 5. Notice that's just reducing this fraction, this ratio being reduced. It is important to understand that the ratio gives us a relative comparison. A ratio of 3 to 5 for this situation does not mean there's 3 alpacas in my herd and 5 alpacas in your herd. It means that that's what the ratio is. You're comparing, it's a relative comparison. Saying the ratio of 3 to 5 means that for every 3 alpacas in my herd, there are 5 alpacas in your herd. So we're into our ratios now. So this is what it means, and just looking at it visually. If the ratio is 3 alpacas in my herd to 5 alpacas in your herd, that means the same ratio is 6 to 12. 6 to 10, or 9 to, how many would it be? 3 sets of 5, 9 to 15, right? So those are all the same ratios. Just looking at it a little different because they're all equivalent. They're all equivalent fractions, and that's really basically what it comes down to. Note, 3 to 5 is equivalent to 6 to 10 is equivalent to 9 to 15. Notice the similarity to equivalent fractions. Now, if you want to know the absolute number in our herds, you need to know the relative ratio, in other words, any one of these ratios, and one of the absolute numbers. So here's an example. The ratio of alpacas in my herd to your herd is 3 to 5. If I have 30 alpacas in my herd, determine how many are in your herd. So with this information, we can find out how many are in your herd because we have the ratio and one absolute number. Note, you can find the number of alpacas in your herd because we know the relative ratio and one absolute number. Now, there's 2 ways to proceed. Now, this is in your book, so you can just scale it. You can just say, like, number line. 3 is to 5, as 6 is to 10, as 9 is to 15, as 12 is to 20, etc., etc. So you get the idea, right? 3 is to 5 is equal to 6 to 10. Ultimately, you can go all the way to 30 to 50, and you can say, well, there's 50 alpacas in your herd. Now, there's a shortcut to this to determine how many 3s go into 30. I have 10 groups of 3 alpacas in my herd, so each of these groups you have a corresponding group of 5. Look at this. Does this look familiar? The ratio is 3 to 5. You have 30. How many do I have? Multiply the top by 10 and the bottom by 10, and you get 30 over 50. 3 over 5 is equivalent to 30 over 50. 50 is the number in your herd. This is just an equivalent fractions. Now I'm going to stop this tape here and pick up on 4.1a and go through. We're going to have to do some of the actual problems in this now. But there is a background to the whole chapter. It's really about ratios.